Now we are going to look at adding. I need to spell that right. Adding and subtracting. Okay. Now, the more difficult part about these, like I said, is that in order to add or subtract fractions, you must have a common denominator. Okay. If a problem does not have a common denominator, you must factor the denominator completely and list all of the greatest number, all factors, the greatest number of times they appear in any one denominator. Okay, that's a confusing sentence. List all factors of the greatest number of times they appear in any one denominator. Okay. Then to add and subtract, you find the least common denominator, rewrite each fraction with the least common denominator, add or subtract the numerators, place that result over the least common denominator, simplify further if possible. Okay, that's a lot of words. All right, so let's look at an example and let's make all of these words make sense with an example. Okay, so simplify this guy, 5x over x plus 3 minus 9 over x minus 1. Okay. So our first step is we look at this and we say, okay, these do not have the same denominator, x plus 3 and x plus 1. So we need to find the least common denominator. Okay. Basically, we need everything that's in our denominators to be accounted for one time. Okay. So we need an x plus 3 and we need an x minus 1, right? We need that to happen. Now, I'm going to write my problem over again. 5x over x plus 3. I'm going to leave me some room. Minus 9 over x minus 1. Okay, that's what I have. Now, I'm going to put these in parentheses. You don't have to do that, but on the first fraction, I have an x plus 3, but I need x plus 3 times x minus 1. So I'm going to say times x minus 1. And I'm going to do it also to the top. Okay, I have to do it to both places. Okay, well, the opposite happened in the other one. I have x minus 1, and I need x plus 3, x minus 1. So I'm going to multiply it by x plus 3 times x plus 3. Okay, well, now my fraction is written with a common denominator of x plus 3 times x minus 1. So I can write this over x plus 3, x minus 1. Okay. Now look at my numerators. 5x times x minus 1. Okay. If I asked you this in real time, you would tell me, oh, I think you need to distribute that 5x. And you'd be right. I need to distribute my 5x. And so I get 5x squared minus 5x. Okay, what happened on the other one? I'm distributing negative 9 through. Okay, because this is a minus sign. If this were a plus sign, I would be just distributing 9, but it's a minus sign. So we're going to distribute negative 9 through. Okay, so we say, I'm going to do it in a different color. Minus 9x minus 27. Okay. So let's clean it up a bit. We have 5x squared minus 14x minus 27 all over. I'm going to fix that. Was not writing very straight. Over x plus 3, x minus 1. Okay. And we're going to stop there on this one. Okay. Okay, so we found the least common denominator. That's really what I wanted to show in this one. So let's go to this one, okay? Well, we have a bunch of stuff going on, all right, in the denominators. We have two easy trinomials, right? Your first step is to factor your denominators completely, okay? On this last example, there was nothing that we could do to either one of our denominators to make them any simpler than what they already were. Could not factor them. Here we can, okay? So we have 3x over, we have an easy trinomial, and we have x and x, our signs are the same, and they're both negative. And we need the factors of 10 that add to 7, that's 5 and 2, okay? Minus 2x over, we have another easy trinomial, and we have x, and so both of our signs are the same, and they're both negative. And the factors of 15 that add to 8 are 5 and 3. Now, we need to find our least common denominator. Okay, now that we have factored completely, we're going to find our least common denominator. Okay, remember, we need to account for everything in our denominator exactly one time. So we have an x minus 5, an x minus 2, an x minus 5, and an x minus 3. Okay, so x minus 5, we have that 2 times, but we're only going to account for it once. X minus 2 and x minus 3, okay? That whole line right there accounts for everything in our denominator exactly one time, okay? So now we need to look at what do we need to multiply by, okay? Well, our least common denominator, so we can write our next line that looks like this. We're going to write this all over one bar. And we know that our denominator is going to look like this, right? That's our least common denominator. Well, if you look at this, you need to say what's missing. I have x minus 5 and I have x minus 2. So we're missing x minus 3. So what you do to the bottom, you need to also do to the top. And then we're missing x minus 2. So we're going to multiply by x minus 2 on the top as well. Now we're just going to distribute. Okay, so we get 3x squared minus 9x. Then we're going to distribute a negative 2x, right? It's a subtraction sign, so we're going to distribute that negative through with our 2x also. So we're going to get minus 2x squared plus 4x. Okay. Okay, well, let's clean it up. Let's add our like terms. So we have 3x squared minus 2x squared. That gives me x squared. And then we have negative 9x plus 4x. That gives us minus 5x. And it's over x minus 5, x minus 2 times x minus 3. Okay, well, look at this numerator real quick. 2 terms. We need to factor it completely, right? 2 terms, not the difference of squares, not the difference of cubes. So let's take an x out because that's all we have left to do. And so look what we have now. X minus 2, x minus 3. Okay. Now, look what we can do. Our x minus 5s can reduce, and we are left with x over x minus 2 times x minus 3. And then you're done. Okay. So we found our least common denominator where we accounted for everything in our denominator exactly one time. Okay. And we had to factor completely our denominators first. And then we multiplied whatever we were missing by the top and the bottom. We added our like terms. And then we said, is there anything that we can do to that numerator to kind of simplify even more? Because that's our only direction, is to simplify. Our directions aren't subtract these two fractions, they're simplify, right? And so we had to keep going a little bit here when we factored out the greatest common factor, and then we reduced, and we were left with x over x minus 2, x minus 3, okay? All right. Last one, let's do complex fractions, okay? What makes these complex? Well, I don't think that that's very difficult to answer. You probably have figured it out. You have a fraction in the numerator divided by some fractions in the denominator. I would say that sounds pretty dang complex, okay? So here's what you do. We are going to multiply by our least common denominator, okay? So if we can multiply by x squared, let's multiply every single term in our numerator and every single term in our denominator by x squared and see what happens, okay? So I'm going to write, I'm going to write this over again, and I'm going to leave me some space. Okay. Now I'm going to write the denominator the same way. 13 over x plus 15 over x squared. So let's multiply by x squared. See what happens. Times x squared, x squared, x squared, and x squared. Okay, well, when we did that, look what happened. Let me zoom in. Well, 1 times x squared is just x squared, right? Nothing fancy about that. We just got x squared. We have 3 over x times x squared. So we're multiplying 3 over x times x squared. Well, we can reduce. And we are just left with an x in the numerator. So we have minus 3x. Notice how my denominator of that little fraction went away, okay, by reducing. We have x squared over x squared. Well, that's just 1. So we have minus 10. All right, now let's do the bottom the same way. 2 times x squared is 2x squared. Okay, then we have x squared over x. Again, that's the same thing that we had up here. So we reduce, and we're just left with x to the first in the top. So that's minus 13x. Plus, we have x squared over x squared. Okay, that just leaves us with 1. So that's just plus 15. Well, something great just happened. Now we only have a rational expression. We have x squared minus 3x minus 10 over 2x squared minus 13x plus 15. And that is certainly something that we know how to deal with. Okay, that's an easy trinomial over a hard trinomial. So we're just going to factor. We have x and x. Our signs are different. Okay, that negative sign told us that. So we need the factors of 5 that add. I almost told you the answer. We need the factors of 10 that add to give you 3, which are 5 and 2. Okay, we need our 3 to be negative though. So we're going to give our bigger number, which is 5, our negative, and our smaller number, our positive, over. So now we have a hard trinomial. So you can either do bottoms up or you can do trial and error. Okay, if you're going to do bottoms up, go over to the side, do bottoms up, and place whatever you get right here. Okay, I'm going to do trial and error. This is where trial and error kind of pays off because you don't have to go over to the side and do it. You can just do it right here. Okay, so I have 2x and x, and my signs are the same and they're both negative. I know that I'm going to have 2x and x because the only factors of 2 are 2 and 1. Okay, so I know I'm going to have a 2 and a 1 in those places. And then the factors of 15 are 1 and 15, 3 and 5. Okay, so I know I'm going to use 3 and 5. Okay, because I need them to add to 13. Okay, and 1 and 15, well, 15 is already bigger than 13. So we know we're not going to use 1 and 15. So if we put our 3 here and our 5 here, that gives us negative 3x minus 10x, which is negative 13x, which is exactly what we wanted, right? Okay, now we can cross out. So we have x minus 5 and x minus 5, and we are left with x plus 2 over 2x plus 3. And we're done. Okay, so what started as a very complex looking fraction actually turned out not to be that bad. We just multiplied by our least common denominator of x squared. Okay, and what that did was we're multiplying by something that gets rid of that denominator in each of our fractions. Okay, so it gets rid of the denominator in our numerator and it gets rid of our denominator in our denominator. Okay, that's why they call it complex. It's kind of hard to talk about, but it got rid of both of them, right? And we were just left with trinomial over trinomial, which is something that we know how to deal with. So each time you're going to look at what you're given in your denominators and say, okay, what can I multiply by? What's the least thing that I can multiply by that gets rid of all of my denominators in each of my numerators and denominators, okay? And that is section P6.